Chapter 21, the chi-square test. Remember, there were two chi-square tests that we did. There was the goodness of fit test and the test of association. That's why there are two chapters, one for each. And they are explained in plenty of detail to fully understand them. It goes over the hypotheses, the test math, how to interpret the results, the conditions, everything you need to know about it, right? And then if you go down to the check your skills section, again, at the end of every chapter, we have these bunch of multiple choice questions. And I took the questions from here. A cross of white and green summer squash plants gives the following numbers of squash in the second generation, the F2 generation. We've all done a little genetics, right? So we kind of know what that's talking about. 131 white squash, 34 yellow squash, and 10 green squash. Are these data consistent with a 12-3-1 dominant epistatic model of genetic inheritance, white being dominant? Use this information for exercises 21.14 through 21.21. The null hypothesis for the chi-squared goodness of fit test is, for this test, it would be the distribution is not uniform. B, the distribution is uniform. The probability of being white is equal to the probability of being yellow is equal to the probability of being green, right? The three different kinds of squash. Or the null hypothesis is C, that the probability of being white is 12 divided by 16. Probability of being yellow is 3 divided by 16, and the probability of being green is 1 divided by 16. If you think about it, you can answer this question. Read through the example. You can answer this question. And then the alternative hypothesis is that the distribution is not uniform, that the probability of white is not equal to the probability of yellow, not equal to the probability of green, and that, or that the null hypothesis is not true, right? You choose, read about it, figure it out. The expected count of green squash, I probably won't give you that one. And I probably won't make you calculate the chi-squared component. I probably won't make you do that unless I give you the formula. If I give you the formula, yes, but otherwise I'm not going to make you memorize all the formulas because that's cruel and unusual punishment. And then the degrees of freedom. This is not going to be on there because I'm not going to give you the table for looking up p-values. That's not something we ever did in class. At the very least, make sure that you read these questions ahead of time, because these examples of these studies are a little bit involved. And when you're taking the test, having to read through all of these, if you've never seen it, might feel a little overwhelming. But you all have the opportunity to read all of these. And I'm not putting anything in there that's not in the book. They're not all from Check Your Skills. Some of them are from inside the chapter, but there'll be questions just like this. And a lot of them are these very questions. Sometimes I change them a little bit, mostly to make them simpler. A very large pediatrics office is open for business Monday through Friday. Management wants to know if antibiotics are prescribed uniformly over the work week. Keyword uniformly, right? All the equal probabilities. We did something like this in class too, didn't we? A random sample of 20 antibiotic prescriptions written over the past 12 months is the null hypothesis for the chi-squared goodness of fit test is The distribution is not uniform. The distribution is uniform, which is that the probability of a prescription written on Monday is equal to the probability of Tuesday, probability of Wednesday, probability of Thursday, probability of Friday, or 1 out of 5. Or the null hypothesis is that the p equals 0.5. The probability is equal to 0.5, like 50-50. And think about it. What do you think?
B.
B, right? Makes sense. It's B. Uniform probabilities on all days of the week. And then if the software gives you a p-value of less than 0.01, your conclusion based on this test, right? This is sort of like your alternative hypothesis, is that the data are consistent with a uniform distribution. B, the data provides strong evidence that all 5 proportions are different. Or the data provides strong evidence that the distribution is not uniform. Would it be A, B, or C? We know it's not uniform. We know it's not uniform, but we don't know that they're all different. We just know they're different.
Was it C?
It is C. Yeah. Okay, it doesn't say that all 5 proportions are different. All we know is that one of those proportions is different. We can't tell from the p-value which one is different. We can just say that something is not equal.
Okay.
Okay? The next chapter